So welcome back. Today, in this session we will make this one exhaust manifold. So this exhaust manifold is a combination of many curves. Okay, one when we view from the front side, it is like this one, and when we view from the side, okay, when we consider this pipe. So when we view from the side, it look like this one. Okay, it look like. It is not clearly. It is not possible to draw clearly in the two-dimensional paper. So yeah, let's see the figure dimensions. Yeah, when you view for this pipe one, when you view from the front view means YZ plane, right? When you view from the front, so the curve is looking like this. Center curve is looking like this one. Okay, yeah, up to here. So when we view from the side, okay, the center curve for the pipe one look like this one. Okay, so side view, right? This one is side view. Side view is jet explain. So similarly, for the second pipe, so when you view from the front side, the curve is looking like this one. And when we view from the side, same, the curve is looking like why here when you view side view is viewed, right? When you view from the side, so the pipe is same. We can see only one pipe. That means all the pipes, this curve is same. Okay, this curve is same. But when you see some other projection, okay. So suppose here there is another projection like pipe, maybe another pipe projection like this one. The center curve is different, and we have to draw for the second pipe. We have to draw the center of this curve. Okay, center of this pipe. So, but here, in this case, the center of the pipe one and pipe two, when you view from the side, is same. So same curve. Okay, same curve. So, but front view curve is this one. Okay, for the second pipe, and remaining two pipes. So when we finish this one, right, and we draw curve on YZ plane like this one and curve on ZX plane like this one, and combine those two curves to get a common curve. Okay, common curve. So common curve is a different shape. Okay, different shape. Okay, and after finishing these curves, and also we need to do some other modification here. We have to give some 3D corner here at the 3D corner. Okay, because here this is straight. Okay, this is straight pipe. So a 3D folded pipe is connecting to the straight pipe, right? So we have to create a 3D corner with radius 20. And similarly here also is a 3D fold, okay? So 3D fold is connecting to straight pipe. And here also we have to use 3D corner, okay? And we have to create lines. So here lines, and also here also we have to create lines and 3D fold. So those are the different tools we use. The first make the 3D curve of this one. Okay, so from here, from here, sorry. So actually from here to here, so when we make 3D curve, it only creates from here to here, and remaining we have to use another option, so 3D corner and line. So anyway, so let's start making let's consider this is a pipe 1 and pipe 2. So first make curve for pipe 1. So curve for pipe 1 is this one. Okay. So how to create that one? We select YZ plane and line and curve. You can choose arc with radius 50, and again another curve. Center point is somewhere. Center point of this arc is somewhere, and both are tangent. And up to here, up to the vertical axis, and the length. So from here to here is 90. Yeah, here actually this one is, we can get this arc using 3D corner. Okay, up to here only 90 millimeter. Okay, let's do that one in CATIA. So YZ plane. So select shape, generative shape design. So give name exhaust exhaust manifold. So exhaust manifold. So select YZ plane. So why I am selecting YZ plane? Because so when we view from the front, it's like this. Okay. So select the center curve. Draw the center curve on YZ plane. Okay. So YZ plane. And first draw line. I'm making line 10 mm length on horizontal axis. Not starting from here, somewhere starting from here. Okay. So I don't know that starting point. So 10. So you can choose this option also, continuous line and drag to get the arc. So, but this one is okay. Yeah, connecting this line with another curve, 50 millimeter radius, 50 millimeter radius. So line connecting 50 millimeter radius. Yeah. So arc is better. The circle. If you use circle, you need to trim again. So 50 millimeter radius, and so this arc and this line both are tangent to each other. So tangency constraint. And here again one more arc, another side. Okay, center point is somewhere here. So another arc touching the first arc. Okay. So center point. So avoid the automatic constraints. Okay, here do not start from here. This is okay, and do not start from here. So this arc and up to the vertical axis only. Okay. So the pipe is only up to the vertical axis. Okay. And this is also both are tangent to each other. This arc and this arc both are tangent to each other. So tangency. And here there is some extra projection. So we have to watch carefully whether we have extra projection, or sometimes those two arcs do not touch here, right? If there is no O, means they're not touching each other. Okay. So we have to look those constraints. Okay. Let's delete that one. And from here, so from here to here, the length is 90 millimeter. Okay, 90. So 100 is for this arc. Okay, 100 is for this arc. It's not clear. So 100 is for this arc. So 90 is for the first pipe. Okay, 90 is for the first pipe. And also one more constraint is 20. You see this 20 from this point, both arcs meeting at a point, right? That point to the vertical axis, 20 millimeter. Okay, so give the 20. So from this touching point, both arcs touching at that point to the vertical axis. So 20. And radius of that arc is, so radius of this another arc, second arc is 75. 75 is not given. So 75. Yes. So that one is finished for the first pipe center on YZ plane. Okay. When we view from the front side, the first pipe center look like this one. Yes. So for making second pipe center, we have to use another curve. Okay. Another. So this is also on YZ plane, but should be a different sketch. Okay. You should not make here. So if you make here means both are same sketches. So different pipe, different sketch, okay? So another sketch on YZ plane. So for second pipe, okay? And same 10 and 100 and 150, okay, like this one. So it should line same way as before. So 10, I can give dimension later, and 100, and so this arc and another arc 150 up to here, same way as before, okay, but the dimensions are different. So 100, sorry, 110, and both are not touching here. Be careful. So we can make these two touch together, right? So use the coincidence constraint. If there is no means, no O means not touching each other. And radius of this arc is 150. No, 100, sorry. 100. And radius of this arc is 150. 150. And both arcs tangent to each other. There is no tangency constraint here. Okay. So when you draw, if there is a tangency constraint, there is you don't need to give. But now there is no tangency constraint. You can give that one. And yeah. So this 100. What is this 100? So from the horizontal axis to the ending point of that arc. Okay, second arc. So from here to here, 100. So still not fully constrained, this because I did not provide this distance from here to here. So in dimension, it is mentioned 16, okay, from this point, connection point of the two arcs to the vertical axis. So 16 limit. So from this point to this, yeah. So now you can see the complete green is fully constrained, okay. Okay. So after making that one, so only front side are finished, and yeah, this is not a planar curve, right? So yeah, when you view from the front, it's like this one only, and when you view from the side, it's like this one, and when you view from the top, it's like this one. So combination of different shapes, okay? So that's why we have to create another curve, okay? Here, this one. Right view on ZX plane. And you can also create this curve, okay? If you want, you can also create this curve on top view, right? Top view is XY plane, but there is no dimensions here for this curve, right? For this center. And here, yeah, combine this curve and this curve, you will get some different curve. Or combine this curve and this curve, you will get some different curve. Both are same. So yes, so dimensions are given on only ZX plane. So ZX plane. So that's why, I mean, right view, dimensions are given in right side view. So create sketch on ZX plane. Okay, ZX plane. So right view or left view is on ZX plane, right? Let's create sketch on ZX plane. And yeah, make the sketch. So line and curve and line. Okay. So you can make two lines, okay, and give the corner, 2D corner, okay. You can also make this curve, okay. You can also make this curve using 3D curve and 3D lines, and so that is also possible. You don't need to go into sketch mode, okay. So because this one is a planar, and yeah, this corner 50. This corner 50, right? Just draw two lines, and the corner radius is 50. And 30. and this length is 70. So 70 or up to the bottom. So I just give 70 here. So it doesn't matter. So 70. Okay. So that's finished. Yes, now for the first pipe, okay, a combination of this and this curve, the intersection of these two projections, okay, we have to find. So using combine option. So select this curve and this curve, and yeah, select the sketch 1 and sketch 3 for the first pipe. And for the second pipe, sketch 2 and sketch 3, okay? Or you can also select like this one, okay, no problem. So yeah, here combine is this. So click on OK. So this gives the you see when we see a 3D. So when you see the normal view, so why is it fine? It's like 2D, but when we see in 3D mode, it's different, right? A different shape. Okay, that is the 3D curve. And after finishing that one, and again make the combine option for the pipe 3 center. Find the center for the pipe 2. Okay, sorry, pipe 2. This pipe. So combine option using this one and this one. Okay. Yes. Yes, it's looking confusion, right? You can hide. These sketches are no longer needed. Okay. Sketch 1 and sketch 2 and sketch 3 are no longer needed. So you can hide these sketches. No delete. Okay, just hide. So sketch 1, 2, 3. Otherwise, you will get confused. Okay. If you want to keep, no problem. It's up to you. Okay. It's still not finished. This one is not finished. Okay. So this one is a portion of the pipe. So only I just find the portion from here to here. I mean here to just here only. Okay. Here only. Or here to here only. And still we have to do many things. So create a line. Okay. Line and create a 3D corner. Okay. Corner between this line and this curve, okay, this line, straight line here, right? Also same straight line, and we made curve, right? Combined curve, and we have to create corner here. Similarly, here we have to create line here, and we have to create corner at the bottom, okay, 3D corner at the bottom. So first create lines, okay? So line. So at the bottom, I know, right? So for the first pipe, so first pipe is ending. The first pipe is ending here, right? First pipe is ending here. So ending point is only 90, right? 90. So from that point to this point, how much? So from that point to this point, so this is 10, okay? And this is 70 and 50. So 130 millimeter, okay? 130 millimeter. I mean, sorry, total from here to here 130, okay? From here to here 130. Or yeah, just only up to here. Okay, let's create line. So first curve is ending here, right? So 90 millimeter, and from that point to this point, okay, how much? 30 millimeter. Okay, so why 30? So from here to here 70 and 120, and we have 90, and remaining 120 minus 90 is 30 millimeter. Okay, yes, we can select the starting point is a line. Okay, starting point of the line is this one, and so we don't know the second point, so we can create the second point or point and direction, right? Line is just straight line. Okay, so I choose line. So point and direction. Okay. Point and direction. This is the starting point. And direction is, what is this direction? This direction is Z, right? Opposite to Z. Reverse direction you should use. So direction is, so Z direction. And starting is already 0. Yeah, from that point to 0 and ending point, I know, right? 30 millimeter size, total length. And you see it is making line this direction because Z direction is like this one, right? We have to reverse the direction. Reverse. Okay. Okay. And again, same for the second curve also, but here for the second curve, remaining length is 20, right? 20. So only line length is up to 20. So line. Okay. So line. So point and direction again. Point and direction. So the point is this one, second curve, second pipe center point. Okay. I mean center curve point. And the direction is also same, Z component and reverse direction, and the length is only 20 millimeter here. So 20. So because yeah, this one is 30, right? From here to here 30. Because from here to here 90, total 120. Okay. So why 120? So yeah. So from here to here 120, 50 plus 70. Okay. So 120. Yes, I made this line, yeah, actually these two lines, okay, look like only one line, this line are different. And same again, I have to make line like this one, and here again make like this one. Those lines are connecting from, yes, straight lines, okay. So connecting from here to here, right? So those lines. So the problem is I don't know the length of this line, okay. I don't know the length of this line. So I can select direction up to this plane, right? Up to this plane. So you can create a plane first, okay? So 80, right? You can create this plane. So from here to here, 80. Now you will know why I am creating plane. You will know later. So create plane, another direction, right? Not this direction, not towards me, away from me. So 80 millimeter. Yes, now I have to create line up to this plane, right? To the, because this is a 3D line, I don't know the length, right? So you see, this one is joining this from here to this plane, okay, along the x-axis, okay. So, but length I don't know. So here I know length, right? 20 mm, 30 mm, but here I don't know the length. This one is 3D, right? 3D length. So up to this plane I create line. Okay. Similarly, second line up to this plane I create. Okay. So line. So point and direction same here. This point and direction along the x-axis, right? So that direction is this direction. What is this direction? Sorry. What is this direction? X direction. Okay. So reverse of the x direction, we have to use reverse because x direction is towards me, is positive, away from me. So x direction. So end I don't know, right? End I don't know. So we can choose this one up to this one. So you don't need to specify reverse direction. Up to means up to here, okay? Yes. Up to this plane. So along the x direction up to this plane. Same, why I am using up to that plane? Because I don't know. This is 3D line, right? This is not a simple line. It's a 3D line. So this length is not, we don't know that length, okay? That length. Same again, another line, point and direction. Point is this one and direction is x-axis and up to this plane. Okay, not start support, no, end support, sorry. So we have to select this point and direction. Direction is X component, and up to, okay, up to this one. We have to select up to 2. Okay. Yes. Okay. So it's a complicated curve, right? So now I have to make a corner here, right? Corner here, this one and this one. Corner here, this one and this one, 20. And same here, corner here, this one and this one, 20. And corner here, this one and this one, 20 millimeter. So radius of all the corners, 20, 20, 20. Okay, 20, 20, 20. And I can just choose this option. Okay, corner and vertex option. Or if you want to give individually, you can also select the lines and 3D corner option. Okay, so yes, so I select entire curve at a time and corner on vertex option. Okay, so to select entire curve, because now they are separate curves, right? This line is separate, this is separate, this is separate. Join first. Okay, join. So join this and this and yeah, this one, that all belongs to pipe 2. Not everything. Okay, pipe belongs to pipe 2, join, and belongs to pipe 1. Elements belongs to pipe 1, join. Okay, so 2 joins we have to use here. So this one and this one and this one. Okay, so why I am joining? Because I want to give the 3D corner at a time for all the vertices. Okay, here 20 and here 20. Or you can also select individual corners. Okay, individual corners. So that's, you don't need to join them. So because here, suppose here we have 20 radius and here another radius, then we have to select individually. Okay, here you have to select 3D corner option, but here also you can select 3D corner or corner on support, because this one is a planar, right? Planar. Okay. Yeah, that is also 3D, not planar, sorry. That is also 3D. So 3D corner. Okay, so now join 1, select as an element and a 3D corner. 3D corner and radius 20 millimeter. So we have to select corner and vertex option here. Okay, because we have 2 vertices here, right? One vertex is here and another vertex here. So here I want to give 20 and here. So corner and vertex. So when you select corner and vertex, automatically trims. Okay. So yeah. So wait. Not corner support, 3D corner. Okay, you have to select 3D corner. So because this one is not a two-dimensional line, right? So it's a 3D line, and also this is also 3D line. So 3D corner and corner on vertex. That's directly. And same here. Select corner and select join 2 as a 3D corner option. So if you choose this one, we cannot give. Okay, we cannot give corner on support, means only for if the lines are on a single plane. Okay, but here lines are on different plane. Okay, this one is a final curves. Okay, yeah, once you get curves, means very easy now. Okay, so after finishing this one, I choose. Okay, I can select circle here, draw circle here, and draw circle here, and you can choose rib. So, but here, yeah, draw circle here, right? Draw circle here, and rib and center curve option. But here I can directly, okay, sweep, and I choose center and radius. Center and radius. So center is this one, first pipe center, and radius is, okay, here the radius of the cross section is not given. Okay, here outside diameter is 30 millimeter, this pipe outside diameter is 30 millimeter and inside diameter is 20 thickness 2 millimeter and 26 millimeter inside diameter. Okay, so inside diameter 26 millimeter. So I will give outside diameter. Okay, outside diameter, and so we can give thickness. Okay, so outside diameter 30 millimeter, radius is 15 millimeter. Okay, the same here, sweep. Okay, so center curve is this one, and radius same for both the pipes, outside diameter 15 millimeter. Okay, and now we have to delete the common, right? Here there is some, there is some extra projection here for this pipe 1, and similarly for pipe 2 there is some extra projection. How to delete the inside? Okay, inside this extra projections. Okay, this one is for pipe 1 projection, right? And this one is for another pipe projection. So we can trim, right? So trim. So select these two pipes. So there is some message. Okay, yeah, trim the unwanted projections. Okay, so click on OK, and after that, after making this one, so what we have to do, we have to go to part design. Yeah, remaining things. Okay, these things I can use part design. Okay, pad. Okay, simple things. Pad. Okay, pad, all these things. So go to part design, mechanical design, part design. And here, yeah, I already made sweep, right? You don't need to make rib again. If you want to make rib again, you draw circle here and select this is a profile and this is a guide and rib. But I already made sweep, right? So close this sweep. So use close surface. Close surface. So select this one. Okay. So the unwanted here, the color is different because this one is outside is surface, right? I need only 3D model. So hide that surface. So that surface is nothing but trim. And also, this is also, I don't want to see, hide this one. This is also, I don't want to see, hide this one. Okay. Yeah, this one is the pipe. Okay. Pipes, 2 pipes. And other side also same. Other side also same. We can use mirror. Okay. Mirror. Okay, so mirror. So current solid as an option and get explain. So current solid means everything. Okay. Or you can do 2D symmetry. I mean, in generative shape design, symmetry. Okay, symmetry. That's also possible. The mirror. And finally, I need to empty this, right? Empty this one, 2 mm thickness. Okay, actually the cross section of the pipes are not given. I will provide those things. There's 2 mm thickness. Pipes is having 2 mm thickness. Okay. So outside diameter is 30 millimeter and inside diameter 26 millimeter, means thickness is having 2 millimeter. Okay, then so we can give remove this, right? So there is one option, or so here not close surface, after trim use thick surface, that is also possible. Okay, close surface. So sometimes I draw this everything on my own, and yeah, I can't find any details in internet or something, so I draw this everything on my own. So that's why there is some unwanted things if you make the trim and thick surface, so you cannot make. So that's why you can also use shell option. Shell. Okay, shell option. So this pipe and this pipe and this pipe and this pipe, and also this also empty, right? Empty. So bottom also empty, top also empty means we have to select two sides. And default inside thickness 2 millimeter, okay? 2 millimeter. So you know this option, right? I think you might have used in part design when you studied in first year, okay? So click on OK. Yes, so this one, okay? So what remain is I have to provide the fillets or fillets and chamfer 2 millimeter. Okay, we can do that later. So let's provide. So this inside fillet 2 millimeter, 2 millimeter. Some warning. As I said, right, I draw my own, so I don't have any figure. So there are some unwanted warnings and something because the dimensions are not as accurate as. So 2 millimeter, and here also so edge only, we have to select this edge, okay? Or you can make that edge first and you can mirror that one, okay? So that is more convenient. 2 millimeter, okay? Yes, that fillet. And next, what remains is these things, okay? Simple things. So we have to make this one rectangle, 340 millimeter and 60 millimeter rectangle, where here on this plane, right? So we made plane 80 millimeter plane, right? Okay, on the plane, so create rectangle. So if you want to see the other side, okay, you can see this normal view. Click on normal view if you want to see the other side, okay? Other side. Exactly 180 degrees rotation. Okay. So centered rectangle, select that centered rectangle and 340 and 60. This length is 60 millimeter and this length is 340 millimeter. And now, after making that one pad, okay, pad in the reverse direction like this one, this is okay. So why? Because here 80 millimeter is up to here, right? So I have to make pad in this direction, okay? So what is the pad thickness? 10 millimeter, okay? 10 millimeter is given here. Yeah, actually it's not given, actually, so just consider this one as a 10 millimeter. So everything 10 millimeter, the bottom one also 10 millimeter means this one also 10 millimeter, okay? You can assume that one. Okay, so 10 millimeter. Okay. Okay, sorry. So we have to, yeah. So normal view. So make holes, right? Otherwise you have to make holes again, make pocket. Or you can project this, okay? This one. These holes project using project 3D elements. You know, right? That option. Well, so this one, project 3D elements. Otherwise, you have to make pocket again, okay, after making pad. Or you can draw circle here and use coincidence option, circle here, coincidence option with that edge, coincidence option with that edge. And easy one is select the edges, inside edges, circle inside, okay, the pipe inside edges, and use this option, project 3D elements, only one time, okay, project 3D elements. So yellow color you can see, right? So I already projected. Okay. Yes. So next is the fillet radius 10 millimeter here, 10. So here, 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 here. So fillet. So radius 10 millimeter. So object to fillet is this one. So 4 edges. This one, and finally fourth edges. Okay. And again, we have to make the holes. Okay. So we can make these holes in two-dimensional. Okay, in two-dimensional translate option or three-dimensional. Just make one hole pocket using pocket or hole, and you can use transformation feature rectangular pattern. Okay, so just make one hole with the 10 diameter is 8 millimeter, and yeah, from here to here 10 millimeter, from here to here 10 millimeter. Okay, so yes, so make circle, small circle for pocket. So the diameter of the pocket hole is 8 millimeter, 8. And here, from here to here, 10. And from here to here, 10. Right? We can provide those dimensions or directly. So this arc and this both are concentric, right? Concentric, concentricity, having same center. Okay. Or give dimensions 10 millimeter from the center point to the outer edge. Okay. So pocket. So you can choose up to last option or up to next option. And pocket, you can arrange, okay, using rectangular pattern. Total how many holes? 1, 2, 3, 4, 9 holes, and 2 directions. Okay, so one direction, this is 40, and another direction also length 40. Okay, so 40. So 9 holes in one direction, and another direction 2 holes, including this hole. Total 9 holes. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is in the this direction. In another direction, this direction, only 2 holes, 1 and 2. Okay. So rectangular pattern. So 9 holes in one direction, and the distance between 2 holes is center to center distance 40 millimeter. 40 millimeter. And reference element, you can select this one or, okay. So what is that axis? That axis is nothing but edge. You can select this edge, or you can select what is that axis? That axis y-axis. Y-axis. Yeah, y-axis, or you can select this edge. Okay, edge. So along that edge is one first direction. Okay, and the distance between 2 holes 40 and total 9. And second direction, how many? 2 holes, and only 2 in this direction. Okay, and what is the direction? You can choose the z-axis. Okay, z-axis, or you can choose this edge, along this edge. Okay, this edge also along the z-axis. Okay? And it's going up, right? So reverse the direction, and the spacing also 40 here. Yes, here first direction spacing 49 and edge along this edge, this one. Object to pattern is only this pocket. In second direction, 2, this and this one, only 2. And also the distance between center point to center point is 40 millimeter. And along this edge, okay, you can select, or you can select the y-axis. Okay, sorry, z-axis. So that's up to you. Click on OK. So directly give the pattern. And similarly at the bottom, so we can make the sketch there. So which plane? So select this plane, or you can create new plane. So but we already have plane, right? So plane. So once we have surface means we have plane. okay, plane surface. So this is a plane. And same the 80 millimeter, 80 millimeter, sorry, 60 millimeter, 60 millimeter. So 60 millimeter and 10 millimeter is pad thickness, and we have 4 holes. Actually, here only showing 2 holes. We have 4 holes here and here. Okay, so hole size is 8 and 7.5 from here to here. Okay, so yes, 60, and this is also 60. This is also 60, and yeah, there is a hole, 4 holes, 4 sides. Okay, yeah, this side 1 hole. So radius of the hole is 8 millimeter, and from here to here, so 7.5 is given. So you can use mirror. Same here, 8 millimeter, and from here to here also 7.5. You can use the mirror about the horizontal axis. Okay. So that one is pad sketch, and yeah, pad 10 millimeter thickness. So it's going back side, right? Front side, okay, front side. Actually, if it is going back side, okay, by default, if it is going back side means we have to reverse the direction. Okay, yes. Going front side means no need to change. Why front side here? So that sketch I made here, right? I made here. So towards this direction, 10 millimeter. Okay. Okay, and finally give the edge fillet 4 edges. This edge 10 millimeter, this edge 10 millimeter, this edge, sorry, we have to select one more time. So this edge, so only the corner edges, okay. So one more thing here, we have to make the circle also. So there is no hole, right? So if there is no hole means gases does not come out, okay. So yeah, circle, or you can also use project 3D elements. So I will explain the circle option here, circle. So be careful to avoid automatic constraint. And so this circle and this circle both are touching. Use coincidence, okay? Coincidence. Or give the dimensions 13 millimeter. Maybe the diameter is not exactly, okay, yeah. Diameter 26, radius 13 millimeter, okay? Yes. So yes. Finally, and we have to provide fillets here. Fillets, fillets are very important, okay. So fillets, so do you know why we make fillets? So if you don't have fillets, sharp edges, right, sharp edges, so stress concentration is more because uniform area is very less at that sharp edge, right. So more stress concentration on the sharp edges. So to expand that area, okay, along that particular point, we provide fillets, okay, to reduce the stress concentration on edges, okay, edges. Okay, the radiuses are 2 millimeters. And also chamfer also we do to expand the area. Okay, chamfer. So this, and also this also chamfer, 2 millimeter. Okay. Yes. So after finishing this one, you can expand, you can export this to ANSYS or some simulation software, any software like ANSYS, or so there are many simulation softwares. Okay, so to do some simulations. Okay, so yeah, that is the final.